In this section, we will be looking at macro processing in C. So macro processing in C is a very important but least understood area of compilation. Because most of the students or folks, they think that macro processing happens along with compilation. Whereas that is not the case. So what are macros? Macros are text patterns in programs on which meaningful operations can be done. So what do we mean to say when we say that meaningful operations can be done is that if you have the same pattern occurring over and over again in the program, maybe you want to give it a more meaningful, more descriptive name and then use that descriptive name everywhere. This is especially important for large software systems. When we reach the language C++, and that is if you have taken that module, you will realize that there are certain other ways to do it, because over the years macros have proven to be one of the most buggy areas. So the common macro directives, one we have already seen, the hash include file.h. So what this macro is saying is include the file specified by file.h. And the syntax we have already seen, hash include and with less than, greater than, or the file.h can itself be in double quotes. So this directive is going to search in the standard include paths. If we have not specified the path with a minus capital I, it's only going to be in the standard include paths, which are typically /include and /user include along with /user local include on a Linux platform. And it is going to dump the contents of that file in the current file. Another form of the macro processing which is useful is hash define. And we say hash define value space val. So like I just mentioned, this says that a particular value has been assigned to a text pattern. So in most of the C programs, it is not uncommon to do a hash define true 1 and then use true everywhere, because it gives much more meaning to the return value. So suppose say if you have a function and the function can return a success or a failure, you want to return true on success and fail on failure or false on failure. Or you could even change the true to success. But true is much more common in practice. Couple of more common macro directives. Hash define function space definition, and this is something which you will find very commonly in C programs. And as we will see later on, if you have taken the C++ module, there is a way to avoid this kind of a directive because it had several problems. So what this directive does is define a function which expands as per the macro definition. So you can think of it like a regular hash define statement with parameters. So as an example, hash define max x comma y is equal to the definition in parentheses if x is greater than y, then x or y. So what is going to happen is that wherever you have a call such as capital max I comma j, it will be replaced with the pattern I greater than j question mark I colon j. So as you can immediately see, if this particular definition is large or if the definitions are nested, then you are going to have very, very long lines for compilation. And since the macro definition expands then and there, it's just going to be a single line, which is very difficult to debug, especially for large macro definitions. Another usage, and this is the conditions which you can introduce. If parameter is equal to value, then do something. So these parameters must be constants or pattern matchable. And typically you want to put the code there, which is going to be compiled when this particular parameter has the particular value. So as example, if you are writing a code or a program which is going to be compiled with a variety of compilers, and you have made use of some features which are say specific to GCC, then you may want to put a line like this: hash if compiler is equal to GCC, your code, and then hash end if. Of course, you must also provide the mechanism where there should be a different function call or a different piece of code which gets executed if the compiler is not GCC. Otherwise, your program won't execute correctly. Another form of this is the define function, which can be used which only tests whether a particular variable has been or a macro pattern has been defined or not. So the conditional code is included if the parameter is defined. A very common use of this, and this is also there in the standard header files, is hash if defined underscore underscore GNU code. That means the code you want to either make use of the GNU extensions of the code, or the code itself is being compiled as GNU internal, then this is going to get included. Typically you can even negate it with a bang in front of it. Do note that all the macro processing happens before the compilation stage, so there is not very intricate things which you can do here as you can do with a compiler. However, in the C language, lot of things are not present, and macros give you the ability to have conditional compilation or have code which can be made to execute faster because it does not contain any function calls. That is with inline macro expansion. Before we move on to examples of macro processing, let's look at a couple of examples of GCC which are useful for debugging macros. So the most important option is the -E, and what this tells GCC is to stop after the pre-processing or the macro processing step. If you are getting in your compiler an error such as symbol not found and you are not able to find the symbol directly, then what has happened is that the symbol has been constituted using macros, which is not uncommon in code which is say 15 or 20 or 30 years old. Then what you want to do as a first stage is use the -E, stop the program and then inspect the output file. -D symbol in GCC can be used to define a particular symbol. So as an example, GCC -D compiler is equal to GCC will actually force the value of the macro compiler is equal to GCC while doing the macro processing. -d, and these next three options are actually what are passed to the CPP, that is the C preprocessor or the macro processor for C. What it does is it's actually going to output the set of macros defined in the program. And you can couple this with -E to look at the program as well as the macro definitions. -d is going to output the set of macros defined in the program along with the result of macro processing. So with a -d, you will only see which all macros have been defined. You will not see what they expand to. With a -d and a D put together, you will see the macros which have been defined along with their expansions. -d, you can couple it with GCC -E -d to output only the macro names and not their expansions. So couple of tips here. The CPP, as I just mentioned, is the C preprocessor or macro processor. It can be run standalone and the output passed to GCC. The only issue with running C preprocessor standalone is that couple of options of GCC, such as the -include, which can be passed and which is going to add a default include file to all the programs which are getting compiled, cannot be directly passed to CPP. Other thing which you may want to note and which I have been reiterating is that macros increase debugging difficulty and they are prone to bug introduction. And as has been proven over the years, in the C programs, macros are typically one of the most buggy areas. So inline functions and constants, they are preferable. Though if more complicated things are being done with macros, then you cannot use constants. The C++ language has many more features which can be used to make your program much more readable. Here is a sample program along with its output, which we are going to use to illustrate the macro processing step. So as you can notice, the #include line has been commented out, and this is deliberate because if we don't comment out this line, then the stdio.h file is going to get included here and it's going to consume all the space. So we have two macros. One true has been defined to 1, and then max x, y has been defined as we have seen. That is, if x is greater than y, then X or Y as a conditional statement. So there is a printf function which makes use of this particular macro definition, that is max 1, 2. Also, you should note that macro retvel has been used but not defined. So what we are going to do is we use GCC minus capital E, then we use the minus capital D option to define the value of retvel to 20, and then compile the hello world.c program. So couple of lines of output in the beginning. Just note that the entire comment line or the lines of comments have been stripped out. So that is one of the first things which the macro processor is going to do, because the comments are useful for humans, but they don't cause, or rather are not at all useful for the compiler. The next thing which you should note is that in the printf line, the macro definition has been expanded with the appropriate values of 1 and 2. So X was what was 1 and Y had taken the value 2, and the entire pattern has been expanded. It is not as if the macro has found out that okay, 2 is greater than 1. No, it is only a pattern substitution. And this is something which you must keep in mind. So if you have multiple nested macros, they are going to come here and it is going to appear like one big line or statement. Also note that now the value of retvel has been replaced by 20, and that is what is contained in the return statement.